Question number 6. Show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. So you can notice here, this is a quadrilateral, right? A, B, C, D. Now go back to the question. Show that the line segments joining the midpoints, right? So what are midpoints here? This P, Q, R, and S are the midpoints, all right, of a quadrilateral bisect each other. So in short, we're just asked to prove that OR should be equal to OP and OQ should be equal to OS. Okay, we're asked to prove that. So how will we prove this? We'll try to prove that PQRS is a parallelogram, right? Once you prove this, we already know that diagonals of a parallelogram bisect each other, right? So what are diagonals here? This is the first diagonal, right? If they bisect, that means because it bisects, we can say that OR, right? OR should be equal to OP, and also this is the other diagonal here. We know that in a parallelogram it bisects, therefore we can say that OS should be equal to OP, right? So the first thing is we just have to prove that PQRS is a parallelogram. Once we do that, we can simply prove it. Okay, so let's go. Solution: ABCD is a quadrilateral and PQRS are the midpoints of set A, B, B, C, C, D, and AD. To prove PR and SQ bisect each other, or like I said, OP equals OR and OQ equals OS, right? Construction: join AC, right? Join this and also join all the midpoints. Okay, P, Q, R, and S, join this. All right, now for proving, we'll try to take one triangle after the other. Okay, so first in triangle ADC, right? Question really gave us that S is the midpoint of AD and R is the midpoint of CD. Then by the midpoint theorem, can I say that this SR is parallel to AC? Also, we can say that SR is half times AC, right? Because of the midpoint theorem. Now have a look at the other triangle again. Same thing again. They've given us that P and Q, right? P is the midpoint of AB and Q is the midpoint of BC, which means I can say that PQ is parallel to AC, or PQ is half times AC, okay, by the midpoint theorem. So mark this as 1 and 2. Now when you look at this 1 and 2, right, so I've written here for us SR is parallel to AC, again PQ is parallel to AC, right? Then can I simply say that SR is parallel to PQ? We can say. And then also again, SR is half times AC, PQ is also half times AC, which means simply SR equals PQ, right? So now can I say that quadrilateral PQRS, right, is a parallelogram, right? We can say because one pair of opposite sides are equal and parallel, right? We have proved that this is parallel to this parallel, right? And also that those two lines are equal. That means we can simply say PQRS is a parallelogram, right? And now if PQR is a parallelogram, then this RP and SQ becomes the diagonal of the parallelogram, right? And we already know that diagonals of a parallelogram bisect each other. Therefore, I can say that OR equals OP and also OQ equals OS. Right? So this is how we will prove it. How we have proved it. Okay.